So for this section, we will learn the Chapter 2, Section 2, Basic Differentiation Rules. So here's the 3 goals in this section. First one, find the derivative of function using a constant rule. Second one, find the derivative of a function using a power rule. Third one, find the derivative of a sine and cosine function. So we need to use the 3 basic rules in the differentiation: constant rule, power rule, and trigonometric rule. And we do not have to use the limit definition of the derivative to find the derivative of function because it is a shortcut. And we learned the limit definition in the chapter 1, but it is much more complex than using the general rule in the differentiation. So the first one is a constant rule. The derivative of constant number is 0. This is because the graph of a constant is a horizontal line. Therefore, the slope of a constant must be 0. Second one is the power rule. The derivative of function with x raised to a power f of x equal to x to the power of n is f of prime equal to m times x to the power of m minus 1. So let's give some example about these rules. First one is f of x equal to x to the power of 5. So when we use the power rule, so we need to put the 5 as a constant before the variable. So the f of prime equal to 5 times, and the power of the x originally need to be minus 1. So the f of prime equal to 5 times x to the power of 4. Second one is f of x equal to 1 divided by x squared. So first one, we put it as a general form. So f of x equal to x to the power negative 2. And we use the power rule and we put the negative 2 as a constant before the variable x. And the power need to be minus 1 equal to negative 3. So the final function is f of prime equal to negative 2 divided by x to the power of 3. And here's one, f of x equal to x squared and the square root of 3. And as we write as a general form for the x, so f of x equal to x power 2 divided by 3. And we use the power rule and to put the second 3 as a constant before the x, and the power need to be minus 1. So the final result of this is f prime equal to 2 divided by 3 times x to the power negative 1 divided by 3. So here's the constant multiple rule. If f is a differentiable function and c is a real number, and cf is also a differentiable, so let's write it as a mathematical form. F of x equal to c times f of x. Then the f of prime of x equal to c times f of prime of x. And let's get some examples. The first one is f of x equal to 3 times x power of 2, and we use the multiple constant rule. And the constant 3 is not changed, and we put the 2 before the variable x, so f of prime equal to 6x. Second one is the f of x equal to 2 divided by x, and the constant is 2, and we put it before the x. And the power of x is -1, and we also need to use the 2 times the -1 equal to -2. And the power of the x need to be -1 and equal to -2. So the result is f of prime equal to -2 divided by x squared. The third one is f of x equal to 3 times x cubic and the square root of 5. And the 3 is a constant, and we put the rest of it in a general form. So f of x equal to 3 times 3 divided by 5, and we put the 3 divided by 5 before the variable x and 2 times the 3. So it is as f of prime equal to 9 divided by 5 and times x to the power -2 divided by 5. And here's a rule for the sum and difference rule. If both f and g are differentiable, then the sum or difference of x and g is differentiable as well. And we write it as mathematical form is f of x equal to f of x plus or minus g of x. And then it's equal to the f of prime equal to f of prime of x plus and minus g of prime of x. And let's use the sum and difference rule. So here's one, f of x equal to x cubic time plus x squared minus 2. And f of prime equal to 3 x squared plus 2x, and we use power rule and constant rule, get this one. And for another one, f of x equal to 3 times x the power of 5 minus 2, and 2 times x cubic plus 1 divided by x. So the x prime equal to, and we use the power rule and put the first portion of the equation 3 times x power of 5, and we put the 5's power before the variable x. So the 3 times 5 equal to 15, and times x power of 5, which was getting by the 5 minus 1. And the rest of it also would be get from this. And the derivative of sine and cosine function, it is a trigonometric function. So it is much more complex and specific than the others. And the sine x prime equal to cosine x. Cosine x prime equal to negative sine x. So this is it is the basic form for these two forms for the sine and cosine function. Here's the example. F of x equal to 2 times sine x, and we could get the information that from the multiple constant rule, and the constant 2 would not be changed, and we keep it before the sine x, and the sine x prime equal to cosine x, so the f of prime equal to 2 times cosine x. And here's one also could use the multiple constant rule and the trigonometric rule. And for the 1 divided by 2 would be constant before the prime of x, and the sine x equal to cosine x. So the f of prime equal to 1 divided by 2 times cosine x. And the f of x equal to x plus cosine x, and we use the sum or difference rule from the the last session in this course, and the x would be 1, and the cosine x could be get from the general form for the cosine prime would be the negative sine x. So the f of prime equal to 1 minus sine x. And here's another definition or another ideology for mathematical differentiation. Horizontal tangent line. Horizontal tangent lines has many applications in calculus. You can find where the function has a horizontal tangent line by taking the derivative of the function and setting it equal to 0. Because as we know that the derivative is kind of the slope of the tangent line, and the horizontal means the slope would be 0, so we could set the derivative as 0 for the horizontal tangent line. For what value of x do the following function has a horizontal tangent line? Also, the first example for this, f of x equal to 3 times x squared minus 2x plus 1. So first step that we would get the x prime equal to 6x minus 2, and we set it equal to 0 to get the horizontal tangent line. So the x would be 1 divided by 3. For the second one, f of x equal to negative cosine x, and we could get that because the cosine x prime equal to negative sine x, so the x of prime equal to sine x, and we set it equal to 0, so the x value would be 0 pi 2 extra. So for another one is for the homework pages, and the homework will be on the 115, and the question would be from 3 to 22 and 31, 45, 44, 57, 61, and 63. So let's get started from the homework session. When the y equal to 12, so the y prime equal to 0, that will be the same because as we use the constant rule, and for the constant number and their prime would be 0. So for this one, we use the power rule and put the 7 as a constant before the variable x, and the power will be 7 minus 1 equal to 6. So the y prime equal to the 6 times x power of 6, 7 times x power of 6. For this one, to use the same mechanism, and the y prime equal to 12 times x power of 11. For this one, and we could write it as the general form y equal to x power of negative 5 and put it before the variable x. So the y prime equal to negative 5 times x power of negative 6, and we write it as a general form y prime equal to negative 5 divided by x the power of 6. For this one, y equal to 3 divided by x power of 7. So the y prime equal to negative 21 divided by x power of 8. For this one, f of x equal to square roots for the root of x as the 5, and we write it as general form for this is x power of 1 divided by 5 and put it before the x, and we will get the f of prime of x equal to 1 divided by 5 times the x power 4 and the root of 5. The g prime of x, and we could get the gx equal to, from this one is x power of 1 divided by 4, and we get the g prime is equal to 1 divided by the 4 times the x cubic and the square and the root of 4 for the 11. And we could get from this is to use the sine and difference rule and the constant rule and the power rule. So the f prime equal to 1. And the g of x equal to 6x plus 3 by using the constant rule, power rule, and the power and the sine and difference rule. So the g prime equal to 6. For the 13 is f of t equal to negative 2 times t squared plus 3t minus 6. So the x prime of t equal to negative 4t and plus 3 by using the power rule and the constant rule. For the 14 one, y equal to t squared minus 3t plus 1 by using the power rule and the constant rule and sine difference rule. So the y prime equal to 2t minus 3. g of x equal to x squared plus 4 times x of the power of 3, and we use the power rule, constant rule, and sine and difference rule. We could get that the g prime equal to 2x plus 12 times x squared. For the 16, y equal to 4x minus 3 times x cubic. So the y prime equal to 4 minus 9 times x squared by using the power rule, constant rule, and sine difference rule. 70 are the same, and just to change the variable st, and we will get the s prime of t equal to 3 times t squared plus 10t and minus 3. And the 18 is y equal to 2x cubic plus 6 times x squared minus 1. So the y prime equal to 6 times x squared plus 12x. And as we get it as a trigonometric function, and it will be complex and using the power rule and constant rule. So for this one, y equal to pi divided by 2 and times the sine x minus cosine x, and we use the sine difference rule and to separate the two portions in the equation as an individual one and to get its derivative from the differentiation. So for the front of it is, and we will keep the constant pi divided by 2 as a constant number before is a sine x prime, and sine x would be get sine theta would be get as a cosine theta, and the next portion minus cosine theta, and we get that the cosine theta will be minus sine theta, so the rest of it would be the plus sine theta. So the y prime equal to pi over 2 n times cosine theta plus sine theta. And we also could get from this, and g of t equal to pi times cosine t, and the pi as a constant will be keep it from this, and the g prime equal to negative pi n times sine t. For 21, y equal to x squared minus 1 over 2 times cosine x, and we separate as two functions and the two differentiable equation, and x squared equal to 2x, and the minus 1 over 2 times cosine x will be the 1 over 2 be kept, and the cosine x will be the negative sine x, so the y prime equal to 2x plus 1 over 2 times sine x. For the another one, y equal to 7 times 7 plus sine x, so the y prime equal to cosine x. For this one, find the slope of the graph of function at a given point. Use the derivative feature of graphing utility to confirm your results. For this one, the function is f of x equal to 8 over x squared, and the point is 2, 2. And first step, and we could get it from the general form, f of x equal to 8 times x power of negative 2, and we could get the f of prime equal to negative 16 over x cubic. And we substitute the point 2, 2 into the equation, so the f prime of 2 equal to negative 16 over the 2 the cubic equal to negative 2. For this one, find the derivative of function. F of x equal to 2x the power of 4 minus x over the x cubic, and we could write it as f of x equal to 2x minus x to the power of negative 2, and we use sign difference rule. So the f of prime equal to 2 plus 2 over x cubic. For this one, determine the points, if any, which the graph of function has a horizontal tangent line. For this one, y equal to x power 4 equal minus 2 times x squared plus 3. And first step, as we get that, is as we write this to get the prime, and so the y prime equal to 4 times x cubic minus 4x, and we know that horizontal tangent line just to set the derivative as 0, and we could get the solution for the x. So the first solution is x equal to 0, second is x equal to 1, and another is x equal to negative 1. For the 61 is y equal to x times sine x, and the x will be in the domain of the 2 pi and 0. First step, when we get the x prime equal to 1 plus cosine x, and we set it as equal to 0. So the x would be pi, and is either in the domain of the 2 pi and 0. Another one is find the case such that the line is tangent to the graph of function. So the function would be that the f of x equal to k minus x squared, and the line would be y equal to negative 6x plus 1. First step, as we could get that the f of prime equal to negative 2x, and here and we could correspond with the tangent line of y equal to negative 6x plus 1, so we get the derivative as the slope of it is equal to negative 6, so the x would be the 3. and we substitute in the line y equal to negative 17. And we substitute x equal to 3 to the function. So the f of x equal to the k minus 3 squared, and the f of 3 either equal to negative 17, which we could get from the line. So the k value would be negative 8. Thank you for listening.